Hi everyone. This is part 2 of 3.5 where we're talking about the shapes of graphs, and we're going to learn a few more vocabulary words and a few more ways to describe shapes of graphs. So we're going to start with something called extrema, and let's start with the first type of extrema, and that's a relative maximum. Now it has to do with increasing and decreasing that we talked about in part 1. And what we say is wherever a graph changes from increasing to decreasing. So if your graph is going up and then it turns so that it's moving downwards, that point right where it turns is called a relative maximum. Now the opposite of that, if the function is decreasing and then turns so it's increasing, we call that a relative minimum. Now those two types of points together, a relative maximum and a relative minimum, are what we call extrema. That's where the title came from. So in a question, you might be asked to label the relative maximum. You might be asked to label the relative minimum, or you have to know if you're asked to label the extrema, you're being asked to label both the maximums and the minimums. So here's an example. This is a graph, and I highlighted and circled in red 3 points, the point 1, -14, 4, 39, and 6, 7. Now the reason I pointed those points out, those are the extrema. So let's start with the maximum. I said this point up here on top, that's a relative maximum, or I'm going to say relative max for short. Because that's where the graph goes from. If I go a little bit to the left of that graph, remember we're always judging a point as it moves left to right. So as I move through that point, it's increasing, increasing, increasing until you get to that point. But then it turns and it's decreasing after. And that's why it's a relative maximum. Now another good way to think about it, maximum means biggest value or highest value on the graph, and relative means compared to the points around it. So if you look inside just that little circle, the point that we labeled 4, 39 is the biggest point in that little circle. And that's where the name comes from. That's why we call it a relative maximum. Now the other 2 points are relative minimums, because as I move towards them, it's decreasing, decreasing, decreasing. And then once you pass it, it's increasing, increasing, increasing. It's changing from decreasing to increasing. And same thing for the other one. Decreasing until you hit that point, increasing after you go through it. So those 2 points are relative minimums, or I'll say mins for short. I use min for min and max for maximum. So those are relative mins or relative minimums, and that's this point here and this point here. You can have more than one. You can have more than one relative max also, we just didn't in this picture. So they're kind of like the bumps. Anytime there's a bump or a turn upwards, or like you could think of them as peaks and valleys, the topmost points are called relative maximums, and the valleys, the dips, the bottommost points are called relative minimums. All right, so let's approximate the extrema of the graph. So first of all, before I even look at the graph, we know that when I say the word extrema, it means find the relative minimums and maximums. So I'm actually asking you to do 2 things. So let's say the relative minimums we'll put here, and the relative maximums we'll put here. And now let's go find them. So imagine a point moving along the graph. If I start up at that first arrow, it's down, 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 down until it gets to this point right here. And then it turns back up. So that's going to be a relative minimum. And then from there, it's up, 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 up until it hits this point right here. And then it turns. So that's going to be a relative maximum. and then down, 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 down until it hits that point right here. So that one's going to be another minimum. So there's the first thing. Before I try to approximate or tell what they are, let's just find them on the graph and mark them with points. So it looks like I have 2 minimums and 1 maximum. Now let's go and approximate them. Now remember, each one is a point, so it's going to be something, comma, something. And we have 2 minimums and 1 maximum. I'm going to start with the maximum because that's pretty easy. It's right on the x-axis. That would be the point 2, comma 0, because it's over 2 and up nothing. Now for the minimums, the first one doesn't actually, looks kind of like maybe not a whole number to me. Looks like the x value might be negative 1.5 or so. We're just approximating. And then the y value looks like it would be negative 4. And remember, I'm finding that just by doing this. I'm taking the point and I'm saying, where does it hit on the x-axis? That's about negative 1.5. Where does it hit on the y-axis? That's about negative 4. For the second one, I would say the x value is about 4, positive 4, and the y value is about negative 1. So those are my approximations. The relative max, I think, was pretty easy. That's the 0.20. The relative minimum, the second one, also is pretty easy. It looks like negative 4, negative 1 to me. The first one doesn't look like a whole number, just approximate. It's about negative 1.5, comma, negative 4. But I'm just telling, when I give you this type of question, I'm testing to see that you knew what extrema meant, you knew how to label minimums and maximums, and you gave me a point in the general right area. Okay. Our last topic for this section is something called end behavior. And end behavior, well, it's actually exactly what it sounds like. It tells you what a graph does at the ends. So it's saying if you have this graph, what's happening way, way, way off to the ends? What's happening way, way, way off to the left? And what's happening way, way, way off to the right? And we frame our answer like this. We say as x increases, y blank, it does something. That's actually the right end behavior. Then on the left, we say as x decreases, y blank, and that describes the left end behavior. And when you get a picture in just a second, I'll show you what I mean by increasing and decreasing. Now, before I do that, here's the possible answers for what could go in those blanks. When I said as x increases, y blank, these are the possible answers for that. Number 1, it could be increase. That would be if the graph turns up in either direction. We say the graph is increasing or y is increasing. It could be decreasing if the graph is moving downwards on either of those sides. Or it could be a number if the graph flattens out. And I'll show you what that looks like too in just a sec. So let's do this one right here. Let's describe the end behavior of this graph. So first of all, let me on the picture kind of highlight what we're talking about. When I say end behavior, the right end behavior is as x increases, y does something. Now remember, the x-axis is the horizontal axis. So when I say x increases, what I mean is we're going this way on the x-axis. That's why it's the right end behavior. As x gets bigger and bigger and bigger, you're talking about what's happening to the graph way off to the right. So the end behavior to the right, or as x increases, is saying what's happening to this end of the graph right here. Now that end of the graph is pointing down. Down means decreasing. And that's the answer to the question. As x increases, y decreases. And what you've done is you've just described 1/2 of your end behavior, the right end behavior. Okay, now if you want to do the left, you say as x decreases, y does something else. Now as x decreases, to get smaller means you're moving the opposite direction on the x-axis. You're moving this way. As x gets smaller and smaller and smaller, you're moving farther and farther and farther to the left on your graph. So you're saying, okay, what if I was moving backwards? Normally we move left to the right on our graph, but we're saying, what if I was moving backwards? What if x was decreasing instead of increasing? Well, if it's decreasing instead of increasing, your graph is moving to the left and you're looking at the left end behavior. Now, since this graph is pointing up on the left, y is increasing. So we've seen two of the three possibilities. I did say I wanted to show you the third one. What could happen here, let me see if I can squeeze it in here. Let's take me out of there and I'll show you right here. Let's say we had a graph that looked like this. And this is a new example, so pretend like I'm starting over. Let's say I asked you to do the end behavior for this, and you said, okay, as x increases, what is y doing? So you say, okay, well, I know what x increases means. It means way to the right, like this. Well, if I look at the right end of the graph, this arrow right here, see, it's flattening out. It's not going up or down. So the answer is not increasing or decreasing. The answer is actually the number where it flattens out. So what you want to do is go back to your y-axis and ask yourself, where is the line where it's flattening out? If it's at -2, like for my picture that I just drew, you would say as x increases, y approaches -2. And those are the three different answer possibilities I told you about on the last slide. Your answer could be number 1, like in light blue up here. The function is increasing if it turns up on either side. It could be number 2, like in red here. The answer is decreasing if the graph turns down on either side. Or number 3, it could actually equal a number like -2 here if it flattens out. And whenever it flattens out, just ask yourself, where up and down along the y-axis, where is it flattening out? And that number is the answer to the question.